Okay, imagine this, right? You have this geometry problem, and it's so hard it would make even like Olympiad level mathletes just completely confused,
Oh, wow.
right?
Yeah.
And then you take that problem and you just give it to an AI.
Uh-huh.
And not only does it just like solve it, but it comes up with a solution that is so creative, it leaves the actual human experts baffled.
Yeah.
That's what we're looking at today.
Right.
AlphaGeometry 2.
Uh-huh.
This AI is basically cracking the code of like Olympiad level geometry.
Oh, wow.
And you sent over some research papers on this, and it's
Yeah.
pretty next level stuff.
It is really, really interesting, I think. AlphaGeometry 2, it's like, a system that combines a language model with a symbolic reasoning engine. So
Okay.
it's almost like a two-pronged approach. So
Mm-hmm.
you have this language model, which understands the problem, proposes potential solutions, and then you have the symbolic engine,
Right.
which rigorously tests those solutions.
Uh-huh.
And it uses logic and deduction just like a human mathematician would do.
So it's like intuition meets hardcore logic.
Yeah, exactly.
This is not the first time, though, that AI has tried to do geometry, right?
Right. So AlphaGeometry 2 actually builds on its predecessor, which is AlphaGeometry 1. We can call it AG1 for short.
Okay.
AG1 was already pretty impressive. It was able to solve a decent amount of IMO problems,
Okay.
but it definitely did have its limitations.
What kind of limitations? Like, what were the roadblocks that it was hitting?
Well, one of the main limitations, I think, was the domain-specific language that AG1 used.
Okay.
So it's kind of like trying to explain quantum physics, but you only have a vocabulary of like 100 words,
Hmm.
right?
Yeah.
So, for example, if it was asked to find the angle or calculate the ratio, it wouldn't be able to do that.
Really?
It could tell you if two angles were equal,
Okay.
but it wouldn't be able to actually calculate the measurement.
So it could understand the relationships, but that actually solve it.
Right.
Yeah.
And then also, it couldn't do locus problems, which is like imagining a point moving along a circle.
Oh, okay.
It couldn't handle that kind of dynamic geometry.
So it sounds like AG1 was kind of like a promising student, but it really needed a vocabulary upgrade to reach its full potential.
Yeah, exactly.
So what did AG2 do differently?
So for AG2, they completely revamped the language, giving AG2 the tools to understand and express those more complex concepts that AG1 just couldn't.
Yeah.
So predicates were added like compute and concute to deal with those find the angle or calculate the ratio questions.
Okay.
And then they also included predicates like dismec, dissec, and onjec, which are able to express equations
Okay.
related to distances and angles, which was AG1's like Achilles heel.
Wow.
Yeah.
So they basically gave it all of the missing pieces, like linguistically speaking.
Right.
Did that make a big
A
difference?
huge difference.
Really?
Yeah, just by expanding the language, AG2 was able to jump from like 66% to 88% in being able to handle IMO problems from 2000 to 2024.
Wow, that's a massive jump.
Yeah, it was then able to solve, or
Mhm.
at least attempt to solve a much wider range of problems.
But, understanding the problem is only half the battle, right? It still has to figure out how to actually solve it.
Right.
So,
And that's where it gets interesting because, yeah, AG2 doesn't just solve problems. It often does so in ways that surprise even the most, like, seasoned mathematicians.
are you saying that this AI is coming up with solutions that humans haven't thought of?
Yeah,
That's crazy.
yeah.
Now, that's a deep dive.
Uh-huh.
But before we get into that, there's another kind of hurdle, right? Like, understanding the problem is one thing,
Yeah.
but how does it actually, like, get to grips with the information that's in front of it?
That's a great question. So that leads us to one of the key innovations in AG2,
Okay.
and that's automation.
Okay.
So previously with AG1, the researchers had to manually translate the problems from like natural language into a format that the AI could understand.
Hmm.
And that was a process called formalization.
Okay.
They also had to create diagrams for problems that weren't straightforward to visualize.
So AG1 needed like a lot of hand holding. That must have been very time consuming.
Yeah, it was a huge bottleneck, but
Yeah.
AG2 changes that.
Okay.
It actually uses the Gemini large language model,
Oh, wow.
which is the same architecture that powers its reasoning abilities, to teach itself how to formalize the problems
Oh, wow.
and even generate diagrams.
Wait, so it's learning how to read and visualize geometry problems like a human?
Yes.
That's incredible.
Yeah.
Wow.
And it was actually tested on like various IMO problems.
Uh-huh.
And it consistently accurately translated the problem into a format that it could understand and even generated these complex diagrams
Okay.
for problems that would have completely stumped AG1.
So AG2 can essentially read the problem, understand it, and draw a picture of it,
Right.
all without human intervention.
Yeah.
That's crazy. But then, of course, comes the real test, which is finding the solution.
Right. And that's where we get into DDR2,
Oh.
which is the symbolic engine that gives AG2 its reasoning power.
All right, so hold that thought, because we're going to get into the inner workings of this, like, magic in part 2.
How?
This is already, like, pretty mind-blowing, and I think our listeners need a moment to process
Yes.
all of this.
Absolutely. Welcome back. So last time we left off with AG2 actually being able to understand the problem and even visualize it.
Yeah, it was pretty wild.
Yeah.
To draw, essentially.
Pretty much. And now we're going to get into the real core of it,
Okay.
which is how it solves these really, really complex geometry problems.
Okay, and that's where DDR2 comes in, which is AG2's upgraded symbolic reasoning engine. All right, DDR2, break it down for me.
Yeah.
How does this symbolic engine work its magic?
Okay, so imagine you're trying to solve a geometry proof, right?
Mm-hmm.
You start with a few given facts,
Right.
and then you use logic and deduction rules to kind of arrive at a conclusion. So
Okay.
that's exactly what DDR2 does.
Okay.
It takes that formalized problem, those given facts, and it uses this set of rules to just deduce new facts and build this chain of logic, just like a human would.
So it's like a superpowered logic machine just churning through these deductions
Yeah.
at like lightning speed.
Yeah, and one of the significant upgrades with DDR2 is this ability to handle double points.
Okay, remind me what double points are again?
Right, so sometimes you have 2 points in a diagram that might look different.
Right.
And they might even have different labels,
Okay.
but they're actually the same location.
Okay.
Which sounds simple, but it actually allows for all these problem-solving strategies that wouldn't be possible otherwise.
So essentially, it can take these problems where 2 points might look different on the diagram, but are actually the same point, and then use that to its advantage
Right.
to come up with a solution.
Yeah.
That's pretty wild.
Yeah.
It's not just like following the set path. It's like being able to see the problem from multiple angles.
Yeah.
That's really cool.
Yeah, and then there's also some algorithmic improvements that have made DDR2 even faster and more efficient.
Okay.
You know how a lot of these geometry problems, they have similar triangles and cyclic quadrilaterals?
Yeah, those always seem to pop up.
Yeah, so previously, searching for these relationships, it was a very computationally expensive task.
Okay.
But DDR2 actually has these new techniques like hashing to be able to find these relationships so much faster.
So it's not just about being smart. It's about being smart and efficient.
Exactly.
Yeah.
And speed is so important when you're dealing with these problems that have so many different steps and potential pathways.
Yeah.
And then on top of that, they also implemented the core computations in C++,
Okay.
which is a much faster programming language. And this resulted in a performance boost of over 300 times compared to the previous version.
300 times. That's like going from dial-up to fiber optic.
Yeah, it's a huge game changer.
Yeah.
But another crucial aspect that really makes AG2 so successful is the training data.
The training data, you mean like the problems that it learns from?
Exactly.
Okay.
So AG2, it's trained on this huge data set of synthetic geometry problems.
Okay.
So these aren't problems that you would find in like a textbook or anything. They're generated algorithmically.
Okay.
And this ensures this huge variety and complexity.
So they're basically giving it a crash course in every geometry problem imaginable.
Yeah, pretty much.
That's pretty wild.
And they've actually made significant improvements to the actual data generation process itself.
Okay.
So first, they're using larger and more complex diagrams as a starting point,
Okay.
which obviously makes the problems inherently harder.
Yeah, up at the ante.
Yeah.
So that it really has to push its limits. But
Exactly.
how do they make sure that it's not just like memorizing solutions?
Yeah.
Because we want it to think creatively.
Right. So that's where the concept of minimal problems comes in.
Okay.
So instead of just throwing these complex diagrams at it,
Right.
they actually distill these diagrams into the simplest possible problem that still captures the essential geometry concepts.
So it's like removing the fluff and getting down to that core logic of the problem.
Right, exactly.
Smart.
So that ensures that AG2 is actually developing this like really deep understanding of the underlying principles
Right.
rather than just memorizing specific solutions.
Right.
And they've also made this minimalization process a lot faster and more efficient as well.
That's really cool. Okay. So we've got this training data. It's this massive and varied collection of challenging and minimal problems.
Uh-huh.
But even with all of this, finding the solution to one of these problems isn't a straight line, right?
Yeah.
Like there's a lot of exploration involved. There are dead ends.
Yeah.
How does AG2 handle that?
Well, that's where SKEST comes in,
Skest.
which is one of the most innovative aspects of H2, and it stands for Shared Knowledge Ensemble of Search Trees.
Okay, break that down for me. How does that search algorithm work?
Okay, so imagine you're lost in a maze, right?
Mm.
And instead of just wandering around aimlessly, you
Mm.
have multiple clones of yourself,
Okay.
and they're each exploring different paths simultaneously.
Okay.
So that's essentially what SKEST is doing. It's
Okay.
using multiple search trees,
Right.
all running in parallel, each exploring a different approach to the problem.
So it's like a team of AI explorers all going into this maze
Right.
and they're trying to find the treasure.
Yeah, and what's key here,
The solution.
exactly, and what's key here is that these search trees, they're not just working in isolation.
Okay.
They're communicating and sharing information with each other.
So if one explorer finds a promising path,
Yeah,
they tell the rest of the team.
exactly. Any deductions that are made by one search tree are immediately shared with all of the others.
That's cool.
Yeah, so it's constantly learning from its own explorations.
It's like a collaborative brainstorming session on an AI level.
Right, exactly.
Wow.
And these search trees, they're not all identical either. They have these different configurations. Some might focus on breadth, others on depth, making sure that they're covering all the different ways to approach the problem.
Okay, so I'm starting to get a picture of like the interplay between the logic and the deduction and the exploration.
Right.
That's happening inside AG2. But there's one piece we haven't really talked about yet, and that's the language model itself.
Yeah.
Because it's not just about like processing information, right?
Right.
It's the intuition. It's about having those aha moments
Mm-hmm.
that can lead to a breakthrough.
Absolutely. So the language model is kind of like this, like, creative genius behind the scenes. And
Oh.
that's what we'll pick up in part 3. It's going to be
Okay.
pretty mind-blowing.
Okay, so we're back and we're ready to tackle like the creative mastermind behind AlphaGeometry2,
Yeah.
the language model.
Right.
So we've covered like the logic, the deductions, the explorations.
Sure.
But where does the real like ingenuity come from?
Well, it's easy to kind of get caught up in the technical details with the symbolic engine and the search algorithms.
Yeah.
But at the end of the day, it really is the language model that's driving this innovation.
Okay.
It's the one coming up with those like really surprising solutions
Uh,
that even like seasoned mathematicians find kind of incredible.
So how does this language model actually contribute to those aha moments?
Well, the main role of the language model is to propose what we call auxiliary constructions.
Okay.
And these are essentially extra lines, points, or circles that aren't specifically part of the problem,
Right.
but can really help simplify the solution.
So they're not part of the original diagram, but
Yeah.
you can add them in to maybe make the problem a little easier to solve.
Exactly. It's like adding a few extra lines to your drawing that can unlock a whole new way of seeing the problem.
That's really cool, but how does it know which constructions to add?
Well, remember this language model, it's based on Google's powerful Gemini architecture.
Right.
And it's trained on that massive data set of synthetic problems that we talked about before.
Right.
So that training really gives it an almost like intuitive sense
Okay.
of which constructions might be helpful in a given situation.
So it's using its experience and knowledge to make a guess about what might work.
Right. But obviously, not every construction that it proposes is going to be a winner.
Right. There's going to be some trial and error.
Yeah, and that's where this really interesting back and forth between the language model and the symbolic engine comes in.
Okay.
So, DDR2 rigorously evaluates each proposed construction.
Right.
And if it doesn't lead to any useful deductions, then the language model will just go back to the drawing board and propose something else.
So it's like a brainstorming session
Yeah,
between like a creative genius and this hardcore logician.
exactly.
That's a really cool way to think about it.
And one really interesting thing that the researchers found is that the language model's ability to actually reason and propose these solutions
Right.
wasn't really affected by whether they used a domain-specific language or natural language during training.
Oh, interesting.
So it seems like it's becoming less dependent on how the problem is phrased and more adept at understanding these underlying concepts.
Yeah, like it's almost developing its own internal language
Right.
of geometric thought.
Exactly. But, it's not just about randomly trying different things.
Right.
There's also this mechanism called an analysis string. Oh, hey, welcome. What's up?
Sorry to interrupt. So the alpha geometry is not a multimodal language, but just a test model in language. Use the formulation to transform image to the test. Is that right?
Okay, that's a really insightful question.
Yeah, it's definitely a key point to clarify.
You're right that the core of AlphaGeometry2, or AG2, is primarily focused on language.
Okay.
It uses a domain-specific language to represent geometric problems.
Uh-huh.
However, it also uses that language to make the connection to images.
So it's not a multimodal model in the sense of, say, taking an image and turning it into text.
Exactly. The image is created or generated based on a textual description of a geometry problem.
So the language model is still the main engine here.
Yes, and the visual component is there to support its reasoning.
Okay, so it uses language to understand and formulate the geometry. Then it generates an image to help with the problem solving.
Yeah, and the visual is used in training, which we can talk more about.
Okay, so just to be clear for the listener, it's not like it's looking at an image first and then trying to understand the geometry.
Exactly. It's the other way around. Does that make more sense?
I-
Oh, yeah, uh-huh.
Oh, thank you for your clarified explanation. Can we wrap up the conclusion and the main takeaway?
Oh, absolutely. I'm glad that cleared things up for you.
Yeah, that's a great suggestion. Let's bring it all together.
Okay, so we've talked about a lot, but let's get to the key takeaways.
Exactly. We've explored how AG2 understands and solves geometry problems, right?
Yeah, from formalization to that insane symbolic reasoning engine.
Right, and how it uses the language model for innovative constructions.
And all of that builds up to these amazing results, right?
Yes, it does, but let's recap that a little.
Okay, so we've talked about the domain language, which was upgraded.
Yeah, so it can handle a wider range of problems.
Right, and the way it can automatically formalize the problems now.
Which really streamlined the whole process for AG2.
And then DDR2, which is way faster than the previous version.
Yes, that is a huge part of why it is so effective.
And the training data, which is much more complex and varied, right?
Right, and the minimal problem approach helps it learn more deeply.
And then the Skest algorithm, that crazy search engine that works in parallel.
Yes, letting each tree share its knowledge with the others.
But I guess you can't forget the language model, which suggests those constructions.
That's right, it's kind of like the creative spark within the system.
But it's not just about creativity. That's the analysis string we were talking about.
Yeah, the analysis string is key because it summarizes everything for the language model.
So it can learn and make better decisions about the next construction.
Right, and it keeps the search really focused.
So at the end of the day, it's this huge collaboration.
Absolutely, between the different parts of the system.
So how with those IMO problems?
Well, AG2 actually achieved an 84% solve rate.
Wow, that's like better than almost all humans.
Yeah, and it comes up with solutions that are just so creative.
That's like blowing people's mind, even the experts.
Yes, it's not just solving the problems, it's solving them in a novel way.
That's so cool. But of course, no system is perfect, right?
Yeah, there's still room for future research, of course.
Like 3D geometry, that's still a big challenge for it.
Right, and inequalities and nonlinear equations are tough too.
But despite those challenges, this is a big step.
It's a paradigm shift in how we think about AI and math.
Yeah, so AG2 is a potential catalyst for discovery.
And it really is something that we should keep an eye on.
This is something that we will for sure be tracking in the future.
It's been a fantastic deep dive. Thanks for joining us.
Yes, until next time, keep those minds curious and those imaginations firing.